Hello everyone, it's Benny, and welcome to part 4. Last time, we implemented this nifty OR logic and flood carry logic in our budding ALU, but it's not quite done yet. So in this video, we're going to add the next critical feature to our ALU, bit shifting. The way this works is actually pretty simple. If I have a number, like say 6, and I bit shifted it, then it would be the same number, except all the bits moved up 1, for example. So this is 6 shifted left. As you'll notice, that number is 8 plus 4, which is 12. So cool. And of course there's another direction I can bit shift. If I took 6 and shifted it right, then I get this, which is 2 plus 1 equals 3. And something you might notice about all that is when I shifted 6 left, that was exactly double what I put in. 6 times 2 is 12. When I shifted right, that's exactly half. 6 divided by 2 is 3. So this is really the key reason bit shifting is so useful. It gives us an easy way to multiply or divide by any power of 2 by just shifting however many times is necessary. And there's actually a whole bunch more uses for it. There's a whole class of algorithms called shift and add algorithms. And using those, you can implement just about any higher order of math function you'd care to. Square roots, trigonometric functions, even some basic calculus can be done like that. It's really awesome. So that is what we're about to implement right now. So to do this, we're going to need to change up our output a little bit. And this is going to give us room to add the bit shifter. So I'm going to set this to position 1, and this all the way down here as position 2. I'm just going to set 0. So actually, I can do one better. Instead of setting 0, I'm going to go this way and move 1. So cool, just gives us a little bit of space, and I can have this right here. I can set this to position 1 and position 2, expand 1 down, and stack 7 down, and there. So this is just giving us a little bit more room. I'm going to do the same thing with this bus. Set this is position 1, and sure, I'll set this is position 2, and I'm going to move 1, and cool. So this has created a whole bunch of torches floating, but that's okay. I can look that up again later. So yeah, I'm going to do... yeah, I'll have the torch right here. So this is position 1. I can type it in. And this is position 2. Going to expand 1 down and stack 7 up. Okay. Put this here. Stack 7 up. There we go. Okay. So all we really need now is just to hook the bus up, so just like this, and stack again. Expand 1 down, stack 7 down. Awesome! So now we've expanded it out just a little bit, and this should be pretty much exactly enough room to add in the bit shifter inside this square right here. Now, when we're finished with this, the way we're going to use it is one input is going to be 0, the other input is going to be whatever number we want to shift. So that's just an important little detail. This is only a one input operation. And something you'll notice is down here, what powers the output when we're doing it like this are these torches right here. So along our XOR bus, these are the buses that tell us what our input is, what number we're bit shifting. And this is important because this is what we're going to need to modify. So yeah, sure, I can leave that on, it doesn't really matter. I'm going to start at the top here, and I'm going to go down one, like this. Actually, yeah, like this. And this is going to go into a torch. This is going to be the input, or not the output, but the output for our bit shifter. So we're going to invert right here, block it off, and I can go down one right here. And you notice this is shifting right. Normally, the wire would go through this torch and this torch onto this wire. If we're bit shifting, it'll go through this torch and this torch onto this wire. And this will require a little bit of logic to disable the torches and make sure everything is powered. That's okay, that's easy enough once we get everything started. So this is position 1 again, and this is position 2. Expand 1 down, and actually expand 2 forward, and put this here. And I think this should be enough to stack 7 down and get the bit shifter. Perfect. Now I can break this torch. And other than that, we'll just need a simple control wire to do this. So I'm going to turn these off now, because otherwise, you'll see right now, it's just sort of, it's not smearing. That's interesting. Oh, because I haven't stacked this yet. Okay. This is position 1, this is position 2. I'm going to put this here for stacking purposes, and stack 7 down. Alright. Now, yeah, we have a little bit of a bit smear because we're outputting both the shifted and non-shifted outputs. So we're going to need a way to control for that. So, the way our control wire is going to work is a little bit like we did flood carry. I'm going to have a comparator powering this block. The comparator is going to be in subtract mode. And something you'll notice is if I power the block, it'll go through the block and power this redstone wire here. If redstone wire is powered, the torch is off. So this is a nice way of disabling our shifted output. The problem, as you see, is if we power this wire, it can reach the output. So I'm going to use another comparator next to it to subtract enough power from this so that it only influences this torch and not the rest of the output. And that's the way we're going to do this. So I'm not going to do the furnace part just yet, I'm just going to stack it. So, yeah, something like this. Going to say, whoops, this is position 1, and this is position 2. Going to expand 1 down. I think that should stack, so I can just stack 7 down. And cool, if I go all the way to the bottom, it should be powering our final shifted output. So it'll sort of be like a shifting carryout, almost. And there. So with that, I should be able to power this, and it should just barely reach the top. So cool. This is how our shifter is going to work. So I'm going to have a lever here, and say enable right shift. Cool. Now we just need appropriately powered furnaces for everything. So this one doesn't need a furnace. It's perfect. This one needs a furnace of power 2. The next one will be 4, and so forth and so on. So I'm going to go ahead and get out all the furnaces that I need. So, actually let me clear up some inventory space here. I do not need this, or a whole bunch of other stuff that I have. So, sure, that's good. And we just need any furnace that's a multiple of 2 at this point. So I need 12. I will need 12. And yeah, so that's 4, 2, good. So yeah, anything multiple of 2. So do not need 7. Do not need 1. And yes, this is a kind of annoying part of doing this. The busing, it's a little annoying getting everything. You know, I'll just destroy everything and get it back out. So I need 2, 4, 6, 8, 10, 12, 14. And I think that's everything. So let's go ahead and add everything. I'm going to put a block here just to make placing these a little bit easier. And there. So that's... Oops, I'll start at the bottom. So I need to subtract... Oops, not 2. Sorry, I'm just starting at the top. The 2 has to be subtracted from this because it's already weak. So there. Next up is 4. There. Then 6. And if you missed it in my last video, if you do not have the fancy furnace setup that I do, you can do this with hoppers and just put in enough until, well, these wires are powered by 1. That's really the trick to this. So there, 10 and 12 and 14. Excellent. So now it should be powering our bit shifter output. So if I power... Sure, let's put in 6. Look at that! You have 6 by itself. I can now add, say, 3, just adds 9. So cool, this is working exactly like you'd expect. So now the only thing we need, and we can't shift immediately, because if I do that, it still goes back to smear. So the only thing we need is some way to disable this ordinary output so that, well, our shifter is the only output that we have. So, the way we're going to disable the normal ALU output is pretty much exactly what we did here. In fact, I'm literally going to set this to position 1. I'm going to go here and go down a bit and set this as position, well, let me go down a little bit more. Yeah, this is position 2. And I'm going to copy. And I can't paste it right here because that would interfere with this wire. So I'm actually going to bust this out by 1. I'm going to go up here a block, and I can now paste right here. So paste. And cool. Now one small problem with this is if I break this torch for just a moment, you'll see power doesn't quite reach the top torch. So we're going to need to power this a little bit differently. So I'm going to replace this with a solid block. And I'm going to say this is where we get power from. And I'm going to relabel this Disable Non-Shifted Output. So if I do disable non-shifted output, you'll see, and I break this torch again, you'll see now it just barely reaches. And in fact, to make this a little bit more obvious, I'm going to go ahead and power all of my inputs. So there. Now, we just need to do pretty much the same thing for everything else. So I'm going to set this to position 1 and position 2. I'm going to expand 1 this way and expand 1 down and stack 7 down. Perfect. And you'll notice all the power is precisely enough, just like before. Well, except for the bottom one. So, what's going on there? Okay, I guess we need a different furnace. So this was subtracting, so that's 15, 14. I need to subtract all but 1, 2, so I should need 12. Okay, it's easy enough. I think I have a power level 12 furnace right here. So there, power level 12, there you go. And now, with that, we should be able to right shift. So, I'm going to enable right shift. Right now, this is indeed right shifting everything. But that's not a very interesting thing to right shift. So, I'm going to right shift the pattern 1, 0, 1, 1, 0, 1. And you notice, look at that, the whole pattern is right shifted. I don't know exactly what number this is in decimal off the top of my head, but it proves our right shifter is working. That is awesome. So, the only thing left to do is left shift. And in some designs, you don't need a left shifter. In some designs, you can just add the same number to itself and say, hey, that's left shift. And logically that works, but in our design, we're going to be shifting by having one specific shifting input and the other at 0. So in our case, rather than doing some complicated bypass that lets one input replace the other, it's easier just to add a left shifter. So yeah, that's what we're going to do. Something you'll notice is that all these wires are just enough power to disable the torch, but not go one more. Except for this one. This one's off by 1. And I think I'll fix that by doing this. There. But the point is, this is how we're going to do left shifting. This block right here will receive power only if, well, an input is on. It won't be interfered with by our disable shifting. So I can, say, put output here, for instance, and you notice this is now on level with the next bus up. So this is just a little bit of a sneaky way of doing things. Sneaky, but nevertheless effective. I can just bus it like that, and what do you know? We have a left shifter. So I'm going to do like this for stacking purposes. And I don't think there's anything else I need to do here to make this work. So I'm going to go ahead and set this to position 1. And I'm going to break this and set this to position 2. Oops. And let's stack one up and see what's broken, because I don't think this is everything. Yeah, didn't think so. So expand one down, or should I expand one up? I should expand one down, I think, and stack one up. Ah, I do need to do that. But other than that, I also need a block right here. Other than that, this appears to be working. So I can go ahead and stack 7 up. And cool. This is left shifting our output. And we do need to connect it all right here, but that's okay. Whoops. And you notice again, because we subtracted so much signal strength with these comparators, they don't interfere with this bus at all. They don't have enough power. And yeah. So this is the basic way we're going to do left shifting. The next thing we need is just some way to bus this, or not bus this, some way to disable all these left shifting torches. So, to disable these torches when we aren't left shifting, I'm going to do the same sort of logic we have here. So I'm going to copy this once again. I'm going to go right here, and set this to position 1, and this to position 2. Perfect. And I can now go right here, and copy. Now I'm just going to paste down the open for a moment to show you something. Right now, this has the furnace going this way. And if I tried pasting it where I'd like it, well, that furnace would overwrite the comparator. So, we can't do that. What we're going to have to do, if I undo for a moment, is face this direction and flip. Now if I paste, you'll see, yeah, furnace is pointing that way. So, now we have enough space to do this. So I'm going to go up 1, right here, and paste. Just like that, we now have a way of doing left shift. So I'm going to say enable left shift. This isn't quite a complete solution yet, because right now it's just powering the bus. We need to go up 1 right here, and there, that's how we're going to power it. So this to position 1, position 2, expand 1 down, stack 7 down, and what do you know? We have a way of disabling our left shifter when we don't need it. Which is actually now confusing me slightly, because I have neither shifting enabled, I have this disabled, and Ah, just a world edit glitch. Okay. So now let's put in our pattern that I did earlier. So this is off, on, off, on, off, on, off. So we right shifted this earlier, and that still works. If I left shift it instead, look at that! So now we can take a single input and shift left or right. Our ALU implements bit shifting. So, that was everything I wanted to cover in this video. Thank you. Hope you enjoyed. Hope you learned. And next time, we're going to be putting pretty much the finishing touches on this ALU, adding just a few more minor additions, and yeah, then we should be done with this. Thank you, hope you enjoyed, hope you learned, and I'll see you next time.